Okay, here's a batch of completed circuit boards. There's 5 of them in the group, just for starters. And then we're going to go ahead and drill some through holes. It's kind of hard to see, but there are little small indications there as to where holes should be located. In addition, locations for the screws that will be attaching the circuit board to the pre-drilled and tapped holes in the enclosure. Well, if you can hear me above the roar of the drill, I'm doing this under some magnification. This goes relatively quickly. Particularly when I memorize where these are located. That was pretty fast, huh? Well. Move to the other bench, and this is a Whitney Roper punch. It's nice setup with a little index in the center of this thing that I'm able to get pretty accurate with, because on the board I've etched a small target spot for that center punched location. And now I'm just going to go ahead and punch out holes, and these are the holes that will mount the board to the box. Try to be pretty accurate with this, because if you miss, you throw the board away. Now I'm hoping that some of these holes can be expanded as necessary, but hopefully we won't have to do too many of those like that. Anyway, that's where we're at when they're done. You know, it's interesting, these mounting screws seem to be stainless. They're not magnetic, I don't think. Anyway, so I had to use the forceps and a screwdriver. And you can see everything lined up, so we've got all of the screw locations correct. Again, if you need to kind of enlarge one of the holes or whatever, these are kind of handy. Or just a little reamer if you've got one small enough to kind of get in. I wouldn't ream them if they are off center slightly. I would try to, get all of the holes you can located, and maybe if you've got an oddball one, just do that one, and only do the side that's associated. If you've got an extremely small jeweler's file or something like that, that would work good. Maybe trying to drift it with a little bit of a, just by hand with a, maybe a 1/16 of an inch drill bit or something like that, to kind of rub back and forth on that side that's a problem. You may need to do that just slightly, but everything seems to line up pretty well in the location of the, probably can't see it real well, but the location of the trace on the foil for the center pin on the SMA connectors looks about right. That one may be off just a tear, but it's not going to be far enough to cause a problem impedance-wise or anything. Okay, we got a bunch of the boards all punched and drilled. And so we're going to start with one here. And we're going to do the rivets that are like through-hole vias. Really reduces the inductance, but primarily conducts heat away from the pad on that PHA-202, which generates a heck of a lot of heat when you think about the wattage that thing is dissipating. These are little silver rivets, and this goes in You can see these little holes in the board, he said. I'm chasing them around in the dish here. Okay, now I think you can see there's 3 rivets there, and I have a little piece of circuit board material. I'm going to cover those so I can flip them over. This is a nifty little tool. You've seen probably these center punches. The center punch is kind of unique in that it has a hardened, whether that's going to focus or not, probably not. But anyway, it's hardened, and it does a beautiful job of finishing off these rivet heads by placing them in center and just running a punch. Bang. And bang. And bang. So that one twice. That one twice. That one twice. Let's see what that looks like. Yeah. Okay. Gonna go ahead and do it for the rest. Okay, I've got a bunch of these done now, and there's one other step I need to do with these rivets. Now notice that they're not quite flush with the top of the board, and I'd really like to have that be the case with the little IC that's going to be mounted there. I don't want the pins up away from the board any further than I really want them to. And of course, on the bottom side, we want to try to get the bottom as flat as possible to get a good heat transfer and such like that without warping the board too badly. So we're going to squish these down a little more than the 10 mils that they're sticking above the board right now. Okay, now I'm over here on the bench that's built with 4x4 and 2x4 type hardwood stuff that's pretty substantial. And got a very high-tech piece of equipment here I'm about to use. A 1/4-inch metal plate, a nail, and for fine-tuning, a hammer. So we're going to do this, and this, and whack it. Now you can't see because I had my hand in the way, but believe it or not, these are now pretty much flat with a surface. Okay, real quick, I'm back on the other bench now to show you. This is the surface situation now after the gentle persuasion. And you can see it no longer has a little hump there. It's dead flat. Okay, the next step in the process is installing the Z-wires, the through-hole wires that provide grounding from the top of the board to the bottom. There's a lot of stuff written about Z-wire and the situations associated with whether you use stranded wire or solid wire or whatever. I feel strongly that solid wire is not the way to go. I use stranded. This happens to be stranded silver plated wire that's available surplus. And I unwind it so that you can see perhaps it's flat. The idea being that if I were to use, say, a number 22 wire, it'd stick up very high from the both sides of the board, which is not good, particularly in the situation where we're going to be installing it in this enclosure, and we want to try to keep it as flat to that surface as possible. So I don't want any bumps on the top or bottom, primarily on the bottom, of course, that's going to be in contact with a flat surface in the enclosure. So again, I use the stranded wire, and I begin by stripping This is a piece of number 28, I think it is, yeah, 28 gauge. I strip a short end and solder right there so that I have a little head on this that allows me to put it through holes in the circuit board without a problem. And then as I pull through, I have a stranded end. I'll show you that. I have a little gazitch on the end here that I needed to cut off, though. There we go. And it's through the board. And I pull it to the point that I've got almost no tail left. Roll it over, flatten it out, and I use something to flatten the ends out. I'm just using the pliers here as an example. And then I can use, if I get a piece of solder here, something with a reasonably sized tip, and just lightly solder that. And I try actually to leave a little bit of the opening on the hole. I use about a number 66 drill bit, and that leaves a little bit of the hole open on occasion, which is kind of cool. Now on the top side, if I can find my knife, this is the first one I've done. Here we go. I just trim that off. And solder the top. And that's where we're at there. And this board is for W4HTB, by the way. Okay, we're back over at the other bench with the board. I've got all of the Z-wires installed. Now we still have some bumps on the bottom, but they're not really big. Now you can either do this with a flat file or maybe some sandpaper. Just place the board down on either the sandpaper or the flat file and kind of run it along the file. You can kind of feel the high spots where the Z-wires were and kind of knock those down a little bit with the file. Try not to get the edges of the board. You'll see how that kind of comes out, and it ends up being, if I can get it here in the video, almost dead flat on the bottom, which is very adequate for what we're going to do, connecting it to the flat surface on the enclosure. Here's a real extreme close-up, we'll call it, of that board with the flattening on the bottom. You can see that typically these things are maybe 5 mils high on the board, which is very minimal and should cause no problems in connecting. The little bumps you see on this top side I've just left alone because they don't really count. They're up, but it doesn't matter. Pretty good.